Okay, so on page 13, this proof is relatively quick as well. The thing that I'm going to require you or remind you to do is to add detail to the diagram. So if we're given that figure ABCD is a quadrilateral, then that means that we should probably add some markings to the quadrilateral, like some green lines showing how A, B, and C, D are the same, and how angle 1 and angle 2 are the same. In fact, looking at it, that makes a zigzag. And anytime we see a zigzag, we know, or we should be able to conclude, that we have opposite sides that are parallel because we have angles that are in between the corners of the zigzags that are parallel or are congruent. So figure ABCD is a quadrilateral, that's given. Line segment AB is congruent to line segment CD, that's given. Angle 1 is congruent to angle 2, that's given. What that means is that AB and CD are parallel lines because they're alternate interior angles that are congruent. The vertical lines right here mean parallel. And if you have congruent AB to CD and parallel AB to CD, having the same two sides be parallel and congruent in length mean that the actual figure is a parallelogram by the definition of parallelogram. Right, you need to do the closing and you need to do the rate yourself section. There's no question for the closing, but I think the thing I'd be is can you list some rules or criteria for proving that a four-sided shape is actually a parallelogram? Because that's what the IntroTask asks you to do. Raul and Katya are asked to prove that a given quadrilateral is a parallelogram. Raul studies the diagonals and observes that they are congruent. So he concludes that the quadrilateral is in fact a parallelogram. Katya agrees that the quadrilateral is a parallelogram, but she agrees for a different reason. So what other information might she have noticed in order for the quadrilateral to be a parallelogram? I noticed there's no diagram myself, so I drew one. And I added some orange zigzag lines because that's maybe what she noticed is that there's actually opposite angles that match, alternate interior angles that are congruent. I added the green zigzag because you got another pair of green angles in between the corners of a zigzag, and they're congruent. And if you have two zigzags, two pairs of alternate interior angles that are congruent, you actually end up creating two pairs of parallel sides. That makes the shape a parallelogram. Raul noticed something different. Raul noticed that if the diagonals are congruent, that makes it a parallelogram. Then that's not true. There are four-sided shapes called trapezoids. In fact, specifically isosceles trapezoids that have congruent diagonals, and they're not shaped like a parallelogram where all sides or there are two pairs of parallel sides. So if Raul is not careful, just saying that the diagonals are congruent is not enough to say that you have a parallelogram. Remember, the other rule with diagonals is that they must bisect each other. So last of all, what type of parallelogram were they studying? I mean, if it's a parallelogram. And they were studying a rectangle. I mean, it's a rectangle because there are two congruent diagonals. And if it's definitely a parallelogram, like Katya discovered, then having two congruent diagonals makes it definitely a rectangle. All right, you must do the problem set. It's a proof. We can work on it together. But it would be really helpful, really powerful, if you would add picture, color, spikes, tally marks, whatever, to the diagram that you're given based upon the information that you know. And then start remembering back the things we talked about. Side, 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 reflexive, other things that we've done in these proof steps to help you answer the question in the problem set.